Alright, this recording is to help you with lesson 4.07, inverse trig functions. The first thing we're going to start with is we're going to evaluate the expression without the aid of a calculator. Alright, so the first thing we're going to do is we're going to set y equal to arc sine square root 3 over 2. Now we need to get rid of the arc sine. So what we're going to do is we are going to multiply both sides by sine, because arc sine and sine undo each other. Those are the inverses of each other. So we get sine of y equals the square root 3 over 2. Right, we're going to turn to our unit circle and see where does sine equal the square root 3 over 2. Well, sine equals square root 3 over 2 at pi over 3 and 2 pi over 3. However, we do have some restrictions between negative pi over 2 and pi over 2. So really we're looking for the values that fall either in the first or the fourth quadrant. So that would be the pi over 3. For part B, we let y equal arctangent of negative square root 3 over 3. So let's take the tangent of both sides so we can get rid of the arctangent. So we get tangent of y equals negative square root 3 over 3. And that happens on the unit circle at negative pi over 6, which is 11 pi over 6 on the unit circle. Okay, next let's use our calculator. So let me bring up mine here. And we're going to find arc cosine and arc sine. All right, on your calculator, when we are trying to find those values here, let's turn it on and clear it. It is your second sine or your second cosine. So I believe we're starting with arc cosine. So second cosine, and then we're going to plug in our value. So negative 0.41. So we should get 1.99. If you don't, make sure that you are actually in your radian mode and not degree mode. Okay, so if you don't get that number, you're in the wrong mode. The second one we're trying to find is arc sine of negative 0.125. And we get negative 0.125. And those do match up to our answer key, so that's always good. All right, next we're going to use an inverse trig function to write theta as a function of x. So looking at, we have opposite over hypotenuse. Opposite and hypotenuse is your sine, because remember your SOHCAHTOA. So the good old SOHCAHTOA is back into play here. So opposite over hypotenuse is sine. So sine theta equals x plus 2 divided by 5. We want to get just theta by itself, so we need to take sine inverse. So whether you denote it with sine to the negative 1 power or arc sine, they're interchangeable. It's up to you. But we should have arc sine of x plus 2 over 5. And that will equal theta. All right, next, I just said that cosine and arc cosine or sine and arc sine undo each other. They're inverses of each other. So in this case, because I have cosine and arc cosine, those cancel each other out, and I am left with just negative 0.1. The next one is a little bit more tricky because it is cosine of arctangent of 2, and it always helps to create a triangle. So I'm going to look at just the inner part first, so it's inside parentheses. All right, let's have y equal arctangent of 2. So let's get rid of arctangent by multiplying both sides by tangent. So now I have tangent of y equals 2, or 2 over 1 to be more exact. So I'm going to create a triangle right here, and I'm going to let this angle be y. Now tangent is opposite over adjacent, so 2 and 1. opposite side, adjacent side. You're going to have to use the Pythagorean theorem to find the missing side. So remember, a squared plus b squared equals c squared. So I have 1 plus 4 equals 5. So c is just the square root of 5. All right, you're going to have to find that missing side because then we want to find cosine of the angle y. So cosine, remember, is adjacent over hypotenuse. So adjacent is 1, hypotenuse is square root 5. You have to rationalize the denominator, so you multiply both the top and the bottom by square root 5 to get your final answer of square root 5 over 5. All right, the next one, same thing. Let's start with the inside parentheses. Y equals arc cosine of x. Multiply both sides by cosine. I'm going to change that so it's a fraction. So when I draw my triangle, I'm going to let this be angle y. Cosine is adjacent over hypotenuse. So when I'm trying to use my Pythagorean theorem, I get the missing side to be 1 minus x squared. All right, now using my triangle, I can find sine of y. And sine is opposite, so the square root of 1 minus x squared over hypotenuse, which is 1. So it looks like sine y is just the square root of 1 minus x squared.